I'm sorry, pardon. Let me see. Are you ready?
Yes, I am ready.
Okay, thank you for Bapak Rimojo and Dr. Lizzy Ofusori. I want to remain for all the participants who are able to please turn on the camera first before we start the class. And I want to remain too for the participants because the class will be starting now. Because it's or one for all participants, welcome to guest lecture 2022. So let me introduce myself. My name is Muhammad Adrian Kusuma from Information System Study Program of Universitas Airlangga 2022. Now I am as your master of ceremony in this class today. And before we start, I want to inform you about the rundown of this class today. This class will be continued by our special speaker. She is Associate Dr. Lizzy O Ofusori from School of Management, IT and Governance, University of KwaZulu-Natal, South Africa. She will bring the topic about descriptive and inferential analysis using AIR programming. After the topic, there will be a Q&A sessions for all the participants. It's open to all the participants to ask questions to our speaker about the topic. After that, there will be a photo shoot together with the speaker. So people will smile. And at the end of the class, there will be a presence and feedback form. For all the participants must fill the form to get the electronic certificate that will be sent to your email. Okay, before going into the class, I will introduce you our speaker first through curriculum vitae or CV. Operator duty are welcome. Maybe for the operators can help to share the screens of. Hey, maybe we should to wait about 1 minute. There is a technical problem by the operators on duty. Okay, thank you for operator for the share screen. Dr. Lizzy Ofusori received her Doctor of Philosophy, PhD, Information Systems and Technology at University of KwaZulu-Natal, South Africa in 2021. She also holds an MSc in Information Technology from National Open University of Nigeria 2012 and BTech in Computer Science from Federal University of Technology in Doctoral Research Fellow, School of Management, IT and Governance, Disciplines of Computer Science, Education and Lecturer Contact in University KwaZulu-Natal, UK. And Soika SA, and her widely research and writes on issues include BioD, mobile security, cyber security, information security, big data, data analytics, and electronic governance. So participants can look at the CV on the screen, and Mr. Dr. Lizzy Ofusori, it's your time, and the platform and the microphones is yours.
Good morning, everyone. I guess it's good afternoon over there, and thanks for this opportunity. So I will be starting the presentation by sharing my screen, just to give you a brief background on the our environment before we go into the practical section. Yeah, before doing that, let me stop this video to just minimize the data consumption from my end. Then thereafter, I can put it on again. So if you can see the screen, you just let me know so I know I'm on track. Can you all see the screen, please? We'll be looking at how we're going to descriptive or inferential analysis. We need to set a foundation. It's our environment, because that's what we'll be using for the analysis itself. So what are the so far? Install her. Hello, can you hear me? Sorry, I think there was a network issue.
It's already enabled.
Oh, okay.
Maybe you the web screen. Okay.
Okay, can you see the screen now?
Yes.
Yes, it's already.
Okay, good. So like I was saying, R is a programming language, and just like every other programming language, it's like we have Java, C++, and the likes. Okay, it's an environment for statistical computing and graphics. It was developed by Bell Laboratories, formerly known as AT&T, and now Lucent Technology by John Chambers and colleagues. Okay, these are sets of students too that came up with this programming language. So it's a challenge for you that you can also come up with something like this. So it's an open source software package to perform statistical analysis such as regression, clustering, classification, and analysis on your data. Okay, moving on, the features of R includes the relational database support. And what do we mean by relational database support? It's a feature that enables R to be able to aggregate your data depending on wherever it is. For example, as a student, you have your student ID. If you go to the admin section and you make an inquiry, they ask for your student ID. Once it's been logged in, they can check how many courses you've registered for, whether you are a resident of the accommodation. So, it brings all the data about you, all the information just by your student number. So that's what we mean by relational database support. Now, the data analytics aspect is what we'll be doing in the practical section, which has to do with the descriptive and the inferential analysis. Another feature of R includes data visualization, whereby it can come in form of diagrams, bar chart, pie chart for it, to summarize your data to be able to see it in visible form. So it has various inputs and extended functions, such as data as extraction. It can extract data from your database, whether it's been stored in Excel. Then the data cleaning also, we'll be doing that even before we go into the practical section, then the statistical analysis, like I earlier said. Now, RStudio, what differentiates RStudio from R? Remember, we are talking about R programming, but we also have RStudio. We said RStudio is an integrated development environment for R. Now, it provides more functionality to R. That's why we need to have RStudio. R is a programming language on its own, but it's limited in terms of functionality. So we need RStudio to be able to extend more functionalities when we are manipulating our data, trying to analyze our data. So that's why RStudio is also very important, and it must also be installed once you've installed your R. Okay, it's also a programming language for statistical computing and graphics. It is available in two formats in RStudio. We have the desktop format, RStudio desktop format, that you can just download and save on your desktop. Then you can open. It's an open source. The second one has to be on the server. Now, it runs on a remote server, and you can only access it through your web browser, but at a required license. So I always go for the first one, which is just straightforward, the regular desktop standalone application. You download it, it's on your system, then you can just open it and work from there. Now, how do you install R? I need to also quickly take you through this, because without installing R, there is no how you can perform any statistical analysis. So I believe you all have your internet browser. You can just log into this. You may not necessarily do it now, but at least you can follow the procedure as I talk. Now, once you open the internet browser, you go to www.rproject.org, click on download our link in the middle of the page under getting started. Then select a crown location, that's a mirror site, and click the corresponding link. Thereafter, click on the download R for Windows at the top of the page. Then click on the install R for the first time. That's if you are doing that for the first time at the top of the page. Then download R for the Windows and save the executable file somewhere on your computer. Then run the executable file, follow the installation instruction. So what you have on the screen is just the step-by-step procedure for you to install R, because you need to have it on your system. Once R is installed, the next thing you need to install is R Studio. Remember, I said they work hand in hand because R Studio provides more functionality to R. So this is also the procedure you have to follow to install R Studio. Go to www.rstudio and click on download R Studio. Follow this procedure, and that's. Now, going to SDS Foundation. What do we mean by SDS Foundation? It's a package that contains many fake data sets. The purpose of now use some data sets to practice. Maybe after this lecture, you can decide to practice. So for to get the procedure on how to download it is also on the screen. I can share this slide with you later on after the process, and you can just work with different data sets in this site. Now, going to the statistics. Now, what do we mean by descriptive statistics? It's a summary statistics that describes summary features from a collection of information. So that just simply put in a layman's language, it summarizes your data, okay? For example, maybe where you collected data that has to do with gender, you have male, female, and of central tendencies, okay? It helps to get the mean of a particular data, and also the median, the mode, and also standard deviation. So all of this can be performed using descriptive statistics, which we'll be doing in a short while. Now, looking at inferential analysis, what does inferential analysis help us to do? It helps us to use the sample data in order to estimate or draw prediction, okay? It helps us to use the sample data, that's your data set, in order to estimate or draw prediction, okay? So demonstration, inferential statistics. The correlation test, which is used to evaluate the association between one or more variables. For example, it helps to test, maybe we want to check the relationship between your age and your height, for example. It can check whether, okay, as your age is increasing, is your height decreasing? Is it a kind of inverse relationship, or are they directly related? Okay, that's what correlation tests help us to do. And we have parametric correlation tests and non-parametric correlations that I'll be explaining in the practical section. For parametric, it follows a normal distribution in the form of a bell shape, while non-parametric didn't do that. You will understand better when we get to the practical aspects of it. Now, the second type of inferential analysis I'll be demonstrating is the regression analysis. Now, what differentiates regression analysis from correlation analysis is that it specifies the effect of the change. Not only does it look at, okay, are they related, but what is the effect of that relationship? And it helps to answer some questions like which factors matters most, how those factors interact with each other, and how certain are we about all these factors. Now, the third type of inferential analysis I'll be showing you also is t-test, which tests if there is a significant difference between the means of two groups related in certain future. So we can check the one sample t-test that has to do with checking for the mean of the sample population against the population and sample. Also, we have another type that is paired sample. What's this course? What is your assessment level? Okay. Based on knowledge about R, as has been recorded. Now, after this lecture has been completed, they took another sample data and they discovered that, okay, there is kind of variation maybe it has improved in your understanding about R. So you're able to compare the two paired sample before and after. That's what it does. Then we also have the independent two sample, whereby it helps to check the variation between two different mean of a particular variable. We have two variables, we check the mean of two different variables and we compare. So all of this I'll be demonstrating in a short while. So now let's move on to the practical aspect, which we are all here for. I just need to provide ground before we go straight into the button. This is the foundation on top where we will build our practical. So I will stop sharing this, then I will share the data set I'll be using and how to clean or how to code your data before we even export it to our environment. So let me stop sharing this and share the data I'll be using for demonstration purpose. Now, this data you are seeing, I believe you can see the screen. This MS Excel workbook. Now, this data you are seeing is measuring customer awareness towards technological use of e-banking system in South Africa. So this is the data you are adding. How do we clean this data? May I quickly inform you that R programming does not understand language we've written here. It can't interpret. We need to clean the data. We need to code it. Some will say coding, some will say cleaning. Potato, we are saying the same thing, okay? So the first thing we need to do is to clean. And the easiest way, like I do tell my students, the easiest way to do the cleaning, which I'm going to show you, is to come through this, your menu bar, you say find and select. Now, let me take this column, for example, this gender column. Let's use that to practice now. I want to clean this, I want to code it. What do? I will come to this find and select and click on this replace. So for female, I will say it should be replaced by a binary number. Mostly they work with binary numbers. So female should be replaced by 1. So all of female replacement of male being replaced, okay, same for male. I will come here and say find and select your menu bar, you see replace. Then I will say for male, replace it with 0. Okay. Replace it with 0. Then I say replace all. So you can see 161 replacements of male has been, entries of male has been replaced with 0. So you can see on the screen. Peradventure, you have another gender. There's another gender. For example, maybe a hermaphrodite or whatsoever. You can also assign a value to it. Okay. Now, having done this column successfully, that is not all. You can see the title gender. This is not, R cannot read this title. Wait, you have to click this gender. Now, may I quickly inform you that anything space bar should be replaced with underscore, because R does not understand, or anything with dots or points must be replaced with underscore. So like we have 1.1, you have to replace it with either underscore value like this. Take out the 1.1. So you can either leave it like this. Yeah, it understands it this way. Or you just take out totally this 1. Leave it at gender. It's underscore if you must include the qualities. You can't use a space bar. It doesn't read a space bar. It only read underscore. Now, we have successfully cleaned this column for you. Expect you to do the same for the other column. Time will not permit me to do all for you, but at least I've shown you the procedure. For this column, you can either give postgraduate 1, diploma 2, and follow the same procedure I use for gender to clean all of them. Then there are some columns that might not be necessary. You may not need them, like the timestamp, and hereby consent, name of participants. All of these are not needed. You can just delete those columns, okay? You can just delete those columns, okay? And just leave those columns you are much more interested in. Another point I want to quickly tell you before we leave this data set, remember what you have on the screen is what we call your data set. And how do you get your data set? Maybe you assign a questionnaire, okay, people to fill in a questionnaire, and when you compute it together, you put everything together, it comes in this form. Another way to get this kind of data set is when you assign a Google form. You know, maybe you've received some Google form, please help me fill this questionnaire and all of that. By the time you enter your details, it comes out in this form. So this is what we call a data set. When I'm saying data set, I'm referring to this kind of platform whereby you have all your information gathered and sample size entered in a spreadsheet, which is Excel. Now, before I forget, you can see under column F, there's an empty cell. There is an empty cell under column F. I want you to take note of that. When we get to the R environment where we'll be doing the practical, I will tell you how to also capture an empty cell, because an empty cell is also an entry. It's also an entry, just that the person, maybe the candidate or the respondent, did not fill in something in this particular one, but if he or she filled other places, but this one is left empty. So I will tell you more about an empty cell when we get into the practical section. So now you understand how to clean data set. If you have a question on how to clean data set, please tell me before I stop sharing this, and because I'm going to share the cleaned one now. Do you have any question on this? Anyone has any question on this before I stop sharing? Okay, I believe we are on the same train. We are good to go. So I was sharing this. I've demonstrated how to clean your data using gender column, and I believe you can apply the same format to the other columns. So let me now share the clean data we are going to be using in our environment. So I will stop sharing this and share the clean or the coded data. So let's go. So can you see the screen? Now I've successfully cleaned my data, and this is what I have. Okay, a clean data looks like this. This is the language R understands. It doesn't understand all the English. So once you do it this way, it understands and it can interpret what you have here. So it has been cleaned, and this is what we are going to be using in our environment. I believe we are good to go. So the next thing you need to do when you have your data cleaned this way, you can save it in two formats. Again, R does not understand MS Excel format. You either save it in .csv, that's comma separated value, or text tab delimited. These are the two ways you can save it for how to understand and interpret. So I will be demonstrating that for you. So you come to your file, just like save as. Okay, where do you want to save it? I have my USB attached. So you can see on the screen, this is CSV. We call it comma separated value. You can either save it in this format or you save it in text tab delimited. The preference is on you, anyone you feel like using. I can use both, but I prefer to go with text tab delimited. So it's CSV, comma separated value. So you choose either of these two and save it in that format. Okay, I already have it saved on my USB drive, so I don't need to save it again. I have saved it as text tab delimited coded on my USB drive, so I don't have to save it again, so I can cancel. But for your own case, you have to save it in a folder or anywhere you just want it to be. So once you've done this, then we can now go to our R environment. We'll open the R Studio and we can start our analysis. So I believe we are all good to go. Okay, let's go. So let me stop sharing this, and I will share the R environment where we'll be doing the analysis itself. May I quickly inform you, it's not complicated, it is easy. Just follow the step-by-step procedure, and I can assure you when you practice it again, you will understand it better. So now let me stop sharing this clean data and let's move on to the practical aspects of it. I'm trying to get where my R is here. Okay. Can you see it? I'm trying to share, but okay, good. Now, are we together? Can we?
Yes.
If I need a response, good. Now, this is R Studio. Remember, I told you how to install R and R Studio. So if you've successfully installed your R and R Studio, this is how R Studio looks like. This is the environment where we are going to be doing all the data manipulation and all of that. So once you have this environment like this, the first thing you need to do, come to File, and under New File, you will see R Scripts. Click on R Scripts, so it gives you an environment. This environment is called a workspace environment. That's where you put in all you need to type. And once you type and execute it, it's being displayed on the console. That's the bottom of this workspace. You can see the console. So whatsoever you type on the workspace up here, the result is being displayed here, okay? We also have the global environment by the right-hand side. You'll be seeing what that does as we go on. Then on the bottom right-hand side, that's where our plots, our charts, histogram will be displayed when we are working with it. So now I always like to start with a comment so that anyone that joins us late, we know where we are and what we are doing and won't just be lost. So for you to type a comment in R, you start with an hashtag and say descriptive analysis, because that's what we want to start with. So anyone that joins us knows that, okay, we are on here. So this is just a statement. A comment starts with an hashtag in R. So once you get to this environment, the first thing you need to do is to set your working directory. You need to inform R where you have your data sets, okay? You must inform R where you have your data sets. So you can see File, Edit, Code, View, Plot, Session. So under Session, click on Session and come to Set Working Directory. Follow it and choose Working Directory. Now you want to use dead or the clean data. I've saved mine on my USB drive and I will say open. Now, inside what I have on my USB drive, okay? Now, you can see I saved one as .csv and I save another one as coded.txt. So the preference is for me to choose which of these one I want to use. Am I going to be working with .csv or .text? But for this particular demonstration, I'll be working with coded.txt, okay? So you can decide to use .csv, but I must warn you, anyone you are using will also determine the kind of function you use, because there is a language you have to use for .csv variable, okay? And we have to do that using the leftward assignment, going through 3 parameters. How time will not permit me to be. So when you read more, you'll be able to follow what I'm trying to say. So I will assign my coded data to a variable. Let me call my variable name my data, okay? This is just my own variable name. So using leftward assignment, less than sign with and high is a symbol for leftward assignment. So I will say read dot table. Now, when I say read dot table, is because I'm going to use with me. When you see that, it does also know the language to use here. So I'm going to use text. That's why I'm saying read table. But if I'm going to use CSV, I'll say read.csv. Are we together? I believe you are following me. So read.table. Then I open the brackets. There's an inverted comma. So what do I want R to read? I want it to read coded text. I want it to read coded text. So I will type it in coded. The way it is, the way I saved it, .txt. That's what I want R to read. Then outside the inverted comma, I will put a comma. Then I will say header. I will set header as true. Let me quickly tell you what that means when you set header as true. You can also pick it here. Now, what I'm telling her about this header is that, remember that you must read those titles. If I don't put this header, that's true. If I don't, variable 1, variable 2, variable 3, variable 4, which I don't want. So I want it to read the title the way I have captured it. So I must also set true. So that's why this is very important. Then you put a comma and say fill equal true. What does this fill mean? I'll tell you just now. Now, remember I showed you an empty cell in the data set, an empty column. And I told you that when we get to this environment, I will show you how we read it. So this field is telling her that even those empty cells must be captured. But if you don't set this as true, it will ignore this empty cell. So that's why we set this as true. Then we have to run. Now, for you to run this program, you can see run up here. You see that you click on this, or you use Control Enter on your keyboard. Either of the two is fine. Okay, so you execute this line of command. Let's execute this line of command by saying now, so it has accepted it. Remember, I said whatsoever you do up here, we appear at the bottom left. So you can see it has accepted it. Now, having done this, instead of me telling how to keep going to my USB file to do all of this, it's better I attach that's my document here. Okay, so it's better I attach. So attach helps for easy references. Attach function is for easy reference of my data set. So I will say attach my data set. I want it to be in this environment. So I will run this line of command because I want it to be here. I don't want it to keep visiting my USB drive to pick it. So once you type attach is a command function. Then my data, remember I've assigned this to my data. So that's why we have my data here. Then I will also click on run. Now, if you look at the console, it has accepted it. How do I know that my data set, the clean one, is now in this environment? You can view it. There's a function called view. Open the bracket and type my data. Okay, then run this line of command. When you run it, what do you have? You can see it has opened another environment for us where you can see my gender, education, the clean data. Okay, so that shows that I've already attached it to this platform and I can work with it. Okay, so this is just another window. So let's go back to our script. This was open beside our script. So let me go back to, now, before we go back to the script, just a quick one. If you see on the right-hand side, you see my data, 402 observation of 49 variables. What does that mean? 402 observations refer to your sample size, the number of rows. If you scroll down, that means the number of rows I have is 402. Variables signifies the columns. The number of columns I have is 49 variables. So this is what this stands for. So it's telling you this 402 is my sample size because that's the total number of people I have here, while the 49 variables is for the column, each column. That's what it stands for. Okay, let's go back to our script. Now, the next thing we need to do is to perform the descriptive. Remember that either mean, median, get all of those things. Okay. Some at times want to check the class of their variable. They want to check the class of their variable, whether it's an integer or what. So you can also, before you even perform the descriptive, you can say class age. Integer. Okay, the console, it has displayed as an integer. You can do that because descriptive analysis, it sets to calculate the mean, the median, the mode, the standard deviation, and it can also display the data visualization in form of histogram. So let's see the mean of age. Let's calculate the mean. So you just age because it's the very. Why am I saying age? Our data here, you can see age is a variable name. So if you don't have a variable name, you can't use it. I have age as a variable name, so I can use it. I have gender as a variable name, I can use it. I have education, so I didn't just come up with age randomly. It's my variable name. So please, so now I'm checking the mean of age. So let's run it. When we run it, it gives us on the console. Remember, the result is displayed on the console. It's trying to tell me the mean of age is 1.8. Remember, have a function. CSV, it will have been mode CSV. So I'm using table now. So mode table, open the bracket as dot factor, okay. Then open another bracket and type in my data, then use a $sign and say H. Okay, so as dot factor, use it. So you can run this line of command. Let's run this line of command. So it has accepted it. If you also look at the global environment, it has accepted it. Now, the way it is, you can actually deduce. But if you want to go a step further, you can go a step further by saying mode. Run this line of command. You can see on the console, 1 appear 203 times, 2 appear 113 times, 3 appear 45 times, and 4 appear 41 times. So from this, we can deduce that our mode is 1. But at the same time, you might not be comfortable with this. You might still want to go a step further by telling her, extract the mode from this. I'm not the one to figure it out myself. I want you to pick it up, and extract that. So you can also try to run it and assign another variable by saying mode age. Okay. When you say mode age, try to open, you use this leftward assignment, names, in brackets, mode, you use this sign, mode, then open, outside this bracket now, open another bracket and say mode double equal to max and bracket and say close this. Now, what you are trying to tell, this function is telling R to extract out of what we have on the console, to extract the highest number. Okay, that's what this function is telling her. So let's run this and see what it gives us. So now you say mode underscore age. Run this. So on the console, it has extracted it that 1 is the mode. So mode is a little bit different from, mean is direct. Mean age, you get the response. Median age, you get the response. But for mode, it's a little bit different because you have to get the highest number that will come most, okay, in the data set before you can even calculate it. So, but for standard deviation, that's SD, that one is straightforward. You can say age and just run this line of command. So the standard deviation gives us 0.999. Now, these are in numbers. You may want to have a data visualization of what you've done. So we can use histogram. You use this function called for data visualization. You can either run it here, like I said, or use Control-Enter on your keyboard. And let's see. So on the right-hand side, bottom right-hand side, you can see the histogram. You can see, so it gives you data visualization. You can also do that for gender, histogram folder. We have gender as one of the variables, so do that, Control-Enter. We have it showing us the number of male versus female, okay? Yeah, so that's the simple, should I say the basic thing I can display to you, demonstrate to you under descriptive analysis. Do you have any question before we take a step further to inferential analysis? Question on descriptive analysis before we take a step further.
Highlight.
Okay, if I get you correctly, you are asking of how to use the pie chart, bar chart. Is that what you asked?
Yes.
Yeah. Now, for App Studio, histogram is an inbuilt program that we can use. But for all of those other charts, you have to, install it. You import it. We call it ggplot. ggplot is one of them. You can also